Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 9 from the International A-Level Edexcel Pure Mathematics P4 January 2022. This is the unused exam, and this question here is about parametric equations as well as volumes of revolution. It says figure 1 shows a sketch of a closed curve with parametric equations: x equals 5 cosine theta, y equals 3 sine theta minus sine 2 theta, and theta is between 0 and 2 pi. The region enclosed by the curve is rotated through pi radians about the x-axis to form a solid of revolution. So how does only revolving around by pi radians enclose or make a whole revolution? Because part of this is above and part of this below, and it's symmetrical. So it's like if you revolve it, this part's going to revolve coming out of the page, and this part underneath, so this shaded region, if say here, will revolve coming out of the page and going around here, and the part underneath is going to revolve in the opposite direction. So it's going to go through half a revolution, this part, and that's going to go through half a revolution, forming a solid of revolution that will look something like this. It will be like a kind of a strange kind of raindrop type of shape. Okay, I didn't draw that very well. So that's why it says pi instead of 2 pi. It normally says 2 pi if it's just like a part above the x-axis or a part below the x-axis. It has to go all the way around to wrap around the x-axis. Here it just has to revolve around pi for it to wrap around the whole x-axis. All right. So that's what we have to deal with here. But still, it's still going to be basically, if I'm going to find the volume of the solid, I have to basically take a section of this, and I have to imagine this section revolving around, the whole thing, including the part underneath, revolving around totally one whole revolution. Basically, it's going to be the same as if it's like this whole of this thing is going to revolve around pi, so the whole thing is going to make a cylinder. So the volume of the cylinder that's formed when you revolve this all the way around the x-axis. So this is going to go from here to there, and this part's going to go from there all the way to there. So you're going to end up with a cylinder basically, and that cylinder has a thickness. Let's call that the height of the cylinder, and this is the radius of the cylinder. So the volume of the cylinder is pi r squared h. So the thickness of the cylinder, we call it dx, and the radius of the cylinder, we call it y, because it's the y value of those points. So the volume is going to be pi times r squared, pi times y squared dx. That's going to be the volume, and we want to find all of the volume of all of those little cylinders from all the way from P to Q. So you have to integrate between pi y squared dx between this value of P and this value of Q. The x coordinate of P to the x coordinate of Q. Okay, if you're doing if you're finding the volume of this revolution in terms of x, that's what we have to do. That's the volume of this solid when when it wraps around the x-axis basically. All right, that's what's going to give us that volume. All right, pi y squared dx. Now the thing is, we have everything in terms of theta here. We have x equals 5 cosine theta and y equals 3 sine theta minus 2 sine theta. So we got to deal with this parametrically. So I've got to have things in terms of theta. So let's set this up. As I mentioned, we got to show basically that this is going to be what we get when we try to find the volume of revolution. We're going to get this expression here, this integral here. So let's start dealing with this. First of all, I know, as I just mentioned there, the volume of revolution is given by pi y squared dx, and this is the x coordinate of P, and this is the x coordinate of Q. So the first thing I need to do is to change this into the form where you're going to have in terms of theta. We're going to use the parametric equations. So we have to deal with this in terms of theta. So I have to change this such that it says pi. I'll keep it as y squared, but I'm going to write this as dx d theta. That's the first step. Y squared dx d theta. Now I know that x is 5 cosine theta. I know x is equal to 5 cosine theta. And I know y is equal to, as we're told, 3 sine theta minus sine 2 theta. 3 sine theta minus sine 2 theta. So y is equal to 3 sine theta minus sine 2 theta. Minus the sine of 2 theta. Alright, so what I'm going to do here is I'm going to take this. So I have v equals pi times the integral. Now here I have to change this into the theta coordinate of p and the theta coordinate of q. Okay, I have to change those into those values. So I'm going to do that eventually as well. But y squared, I'm going to have all of this squared, which is 3 sine theta minus sine 2 theta squared multiplied by dx d theta. Now dx d theta, now if x is 5 cosine theta, dx d theta is minus 5 times sine theta. So I've got times minus 5 times sine theta d theta. So that's what I've got so far. I have to end up with this. All right, now let me deal with the limits. Let me find the coordinates of p and q. So I'm going to just show the steps for it up here because I've got a bit more space. Let me just get rid of this now. Okay, so I need to find the x coordinate of p and q in terms of theta, the theta coordinate of p and q. So I know that p and q are on the x-axis. On the x-axis, y equals 0. So to find the value of theta at p and q, I can put 3 sine theta minus sine 2 theta equals 0. Okay, now how do I solve this equation? Well, I could do it by doing the following. I could use the double angle formula to change these into the same. So this is 3 sine theta minus, you're going to have 2 sine theta cosine theta. That's using the double angle formula. Remember, sine 2 theta is 2 sine theta cosine theta equals 0. I can take out the common factor of sine theta. So I have sine theta times 3 minus 2 cosine theta equals 0. So I have either sine theta equals 0 or I have 3 equals 2 cosine theta, in which case cosine theta equals 3 over 2. Here, well, this is undefined because cosine theta can never be above 1. But here, theta can be, now the values of theta are between 0 and 2 pi, can be 0. Sine theta equals 0 at 0 and also at pi. It doesn't include 2 pi, so it's just theta and pi. Okay, so I know that the values of p and q are theta and pi. Let's find out which is which. Well, I know when theta equals 0, x equals 5 times cosine of 0. Cosine of 0 is 1, so that's 5. So this is where theta equals 0. That's x equals 5. And when theta is equal to pi, x is 5 times cosine of pi. And the cosine of pi is minus 1, so that's minus 5. So this is where theta is equal to pi, when that's x equals minus 5. So let me just put these limits in. So this is going to be between minus 5 and 5. So let me just rewrite this as, this is between minus 5 and 5. Okay, those were when it was in terms of x. And minus 5 corresponds to the theta value of pi. So this is pi. This is pi here. And this value up here is 0. Okay, so now, that's now in terms of this. That's pi and that's 0. Those are the limits. Now I need to make this look like that. Okay. Now what I can do is I can take out this is minus 5 outside. I can see there's a 5 there. So I'll multiply by minus, I'll just multiply this out. So minus 5, I'll take that outside. So minus 5 times pi. Then I've got my limits. This is theta and 0. Now this, I'm going to expand this bracket and see what happens. I'm going to expand this bracket and see what happens. what I'll do actually first, I will, before expanding, I will just write this as 2 sine theta cosine theta, because I can see here that they're all single angles. So I'll make this into single angle as well. So I'll write this as 3 sine theta minus 2 sine theta cosine theta. That has to be squared, and now that's multiplied by sine theta d theta. Okay, so now what we're going to do is we can try to simplify this, but remember, in the end we have to end up with something where we've got something that looks like in this form here. So we could expand this and then multiply everything by sine theta and then try to factorize it. However, what we can spot here is that there's a common factor of sine theta inside this bracket. So we can do a little trick here to try to make it a bit easier, which is we can write this is minus 5 pi, the limits between 0 and pi. Now what I'm going to do here is I'm going to take out sine theta as common from these two terms inside this bracket. So I'll write sine theta, and then I've got 3 minus 2 cosine theta, and this is squared, and then outside it I've got sine theta d theta. Now I can split this up, because if I have, for example, a times b all squared, it's like a squared b squared. So I can write this as sine squared theta and 3 minus 2 cosine theta all squared. So the next step, I could write minus 5 pi between 0 and pi, and this will become now sine squared theta times 3 minus 2 cosine theta squared times another sine theta d theta. And you see here, it's almost exactly what we have to write here. Just can multiply the sine theta and the sine squared theta, and we got what we need, except for one thing, which we'll deal with at the end. So you've got minus 5 pi between 0 and pi of sine cubed theta times 3 minus 2 cosine theta squared d theta. And that's exactly what we need, except for the fact that this should say positive 5 pi and this says negative 5 pi. And what we need to do to fix that is to basically swap the limits around, because when you have the limits this way, 0 and pi, you're going to put 0 in first after you integrate and then pi in. If you do it the other way, you'll get the same value but just the opposite sign. So if I swap these limits and make this pi on top and 0 underneath, then this is going to become positive. The whole thing is going to be positive compared to that. So it's going to basically be the opposite sign compared to that. So then I'm going to have exactly the same what's in here. We haven't integrated yet. We just asked to put it in this form. So 2 cosine squared, 2 cosine theta, and then squared. 2 cosine theta squared d theta. So there's the answer to the question part A. Okay, so we can see that our our alpha and beta, alpha is 0 and beta is pi. Our alpha is 0 and our beta is pi. Okay, according to this, alpha beta. Right? So there's the answer to part A of this question. And now we're going to go on to part B. It says, so this was 0 and this was pi. So now we have to use the substitution u equals cosine theta to show that v equals k pi, where k is a rational number to be found. Okay. So now we've got to integrate this with those limits basically and give the answer in terms of something times pi, where k is a rational number, meaning fraction. Well, it could be an integer as well, but no problem. I think it means it's going to be a fraction. Anyway, we need to use this substitution. So how do we deal with this? Well, we have v equals 5 pi times the integral of, why am I writing that again? We're trying to integrate this expression with respect to theta. Okay, so we're basically, I'm going to say let u, I'm going to get y equals the whole of this thing that we're integrating, sine cubed theta times 3 minus 2 cosine theta squared. That's what I'm trying to integrate. All right. I'm trying to integrate that expression. So what we're trying to do is to find the integral, or 5 pi times the integral of y d theta. That's what we're trying to do. But we introduced a third parameter, which is u. So it's 5 pi, and this is with the limits of theta between 0 and pi. Okay, so we want to introduce a third kind of variable, which is u. So we're going to write y d theta du du. Now these have to be in terms of u now. So I'll call it u1 and u2. Okay, so we have to change the limits in terms of u. All right, and we know that u is equal to cosine theta. That's what we're told. So when theta is equal to 0, u is equal to cosine of 0, which is equal to 1. And when theta is equal to pi, u is equal to cosine of pi, which is equal to negative 1. So this is going to be pi, it's going to be negative 1 up here, and 0 is going to be 1 down here. Okay, I'm doing it in the same place. All right. So we're going to now have to put everything in the right place. So I'm going to replace the y with what it's equal to, which is sine cubed theta 3 minus 2 cosine theta squared, and d theta du. So we know that du d theta, the differential of cosine theta, is minus sine theta. So the theta du, which we have to find, is the reciprocal of that, which is minus 1 over sine theta. So we multiply this by minus 1 over sine theta, and we're going to have du. Eventually we have to change everything so that we're left with only things in terms of cosine theta. So this is a 5 pi out here, don't forget that. So we got 5 pi, and we've got between 1 and minus 1. So 5 pi, we got 1 minus 1. Okay, so now because we had here a minus 1, there's a minus 1 here, we can't forget that minus 1. That minus 1, what we can do is we can take that outside and multiply it over here, so it becomes minus 5 pi. And then we can, we can now deal with this. Here we got to change everything in terms of u. So this is sine squared theta. Now in terms of u, we know that u is cosine theta. Right, so we can take this as 1 minus, this is sine squared theta, sorry, so this is 1 minus cosine squared theta, okay, because we know that sine squared theta plus cosine squared theta equals 1, and we know that u is cosine theta, so that's going to become 1 minus u squared, and this is 3 minus 2 cosine theta, so you can write this as 3 minus 2u squared. All right, and this is now with respect to u. So now we can just replace the cosine squared theta with u squared. So we get minus 5 pi between the limits of negative 1 and 1, and you have 1 minus u squared times 3 minus 2u all squared with respect to u. Okay, now what we should do is we should expand this bracket. So you have minus 5 pi between the limits of 1 and minus 1. And if you expand this bracket, you're going to have 1 minus u squared. And then let's expand the square bracket. This is going to be 9 minus, multiply these together and then double that. That's minus 6u times 2 is minus 12u. And then you square this, gives you plus 4u squared. Okay, we still haven't integrated. We're getting it ready for integration still. That's equal to minus 5 pi. And you have between minus 1 and 1. And then if I expand these brackets, I'm going to get 1 times 9, which is 9. And 1 times minus 12u, which is minus 12u. And 1 times 4u squared, which is 4u squared. And then u squared times 9 minus u squared times 9, which is negative 9u squared. And negative u squared times negative 12, which is plus 12u cubed. And then negative u squared times 4u squared, which is going to be negative 4u to the power of 4. And that has to be integrated with respect to u. And what I can do here actually to get rid of this minus sign here, and I can swap these limits, and this becomes 5 pi, and this becomes 1 and minus 1. And I've got 9, there's no other constant. Negative 12u, there's only That's the only u term. Then you've got 4u squared, and you've got minus 9u squared, which is minus 5u squared. And then you're going to have 12u squared minus 12u cubed plus 12u cubed, and minus 4u to the power of 4. There's quite a few terms there. Now we can integrate. Okay, so now let's integrate everything. So we got now, this is ready for integration. You got 5 pi bracket. So this is going to become 9u. We're integrating with respect to u. So that's 9 times u. The constant gets a u term. This is minus 12u squared over 2. So I'll just do it directly. 12u squared over 2. So minus 6u squared. Minus 5u cubed over 3. So that's 5u cubed over 3. Plus 12u to the power 4 over 4. 12 over 4 is 3. So it's plus 3u to the power 4. And minus 4u to the power 5 over 5. So minus 4u to the power 5 over 5. And the limits now are 1 and minus 1. So now we can put those limits in. So you have 5 pi times, if you put 1 in here, you'll have 9 minus 6 minus 5 over 3 plus 3 minus 4/5. That won't make any difference to it all. The u's will all become 1s. And if you put minus 1, okay, for the odd powers, that will change their signs. That'll be minus 9. And this even power will stay, so it will still be minus 6, because minus 1 squared is plus 1. Here you have an odd power, so minus 1 in there will make this negative, so it will become plus. The sign will change. 5 over 3. This will stay as positive, so that's plus 3. And this will become negative because it's an even odd power, so that's become plus 4/5. Okay, so now let's just simplify this. That's 9 minus 6, which is 3. 3 plus 3, which is 6. In fact, I can just stick this all in my calculator and get the answer out, no problem. Okay, so I can just do that. I have 9 minus 6 minus 5 over 3. Okay, plus 3 minus 4 over 5. Okay, then I have minus, and then brackets, minus 9 minus 6 plus, you got 5 over 3. You got to be really careful in this type of question. It's very easy to make mistakes with signs, even typing things in your calculator. You got plus 3 plus 4 over 5. And then close that bracket and press equals, and we get 196 over 15. So it's 5 pi times 196 over 15. The 5 cancels with the 15, leaving with 3. So you got 196 pi over 3. This is in cubic units, because the volume of revolution. So there's the answer to this question, which is question number 9 from the January 2022 unused paper from P4. Other questions about or from this paper can be found in the playlist over here. Other questions about volumes of revolution can be found in this playlist. Integration questions in general from P4 over here. And you can subscribe to my channel by clicking on this link. Thank you for watching. This concludes the paper, actually, this unused paper. So I hope you understood and benefited from it. Thank you for watching. See you soon. And if you have any other like things you might want to see, any other material that you might want to see, you can look in the description under the video. You'll see some links that will take you to other material that you might be interested in. Thank you for watching. See you soon.